Well, good afternoon. This is Len with Zanga, and in this today's session, we are going to continue with mathematics coverage. And here is exponential equations from the topic of exponents and radicals from two basic mathematics. Previously, we have already covered the rules of exponents. Uh, you remember the product rule, the quotient rule, power rule, zero rule. All those rules were covered, and for your reference, you can actually go to the channel and explore those videos. So to proceed with today's session, uh, talking of exponential equations. Mathematical equations which involve exponents are called exponential equations. So mathematical equation which involve exponents, we call them exponential equations. An exponential equation is of the form we have xc power p equals to y power q, where xc, y are bases and pq are exponents. The laws of exponents are usually used when solving equations that involve exponents, dear students. So all laws of exponents we have covered, they're going actually to be involved when solving the questions involving exponents. And now we're gonna jump actually to the solution. We are going to go to specific cases. For example, consider this case here. If the bases are the same, then the exponents must be equal for the two expressions to be equal. And that is, if we have m power xc equals to m power y, then xc has to be equal to y. And in this case, we just compare the exponents. But also, if the exponents are equal, then bases must be equal for the two expressions to be equal. That is, when you have a power star equals to b power star. So we have seen that actually exponents are equal, and so then bases will be equal. So with this detail in our hand, dear students, let us go to specific examples. So we have to express actually 64 in form of exponents with base equals to 2. So when you break down 64, this is going to be 2 power 6. And so eventually you have 2 power n plus 1. This is going to be equal to 2 power 6. So we have seen that bases are the same. And now we just compare exponents. And with the exponents comparison, when you compare exponents, coming to exponents comparison, an apology for the loss of the screen. But when we compare exponents, we're going to see that n plus 1 will be equal to 6. When you compare exponents, let us come to the screen so that you see how we are going to compare. So when you compare exponents, we are going to say that n plus 1 equals to 60. And so here we'll be having actually n plus 1 equals to 60. And eventually n will be 60 minus 1 equals to 5. So the value of n will be 5, dear students. And we are going to jump to question number 1B. So we are going to jump to B part. Let us see how we can solve B part. So with B part, you'll be having 4 power n equals to 16, and the 16 again can be expressed as 4, actually a number with base 4. So 16 is actually 4 square. So I'll be taking 4 power n equals to 4 square. Once again, bases are the same. We just compare exponents. And in this case, we are going to see that actually n equals to 2. So for part 1, the value of n is 5. And for part 2, the value of n equals to 2. Let us jump to the next question. So we have already seen the exponential equation. We have already seen the exponential equation. And with this exponential equation, so the second example, and that is going to be the second question for our today's session. Find the value of b if you have actually b power 3 equals to 27. So we are going to start with part A. You have b power 3 equals to 27, and 27 can be expressed in terms of a number power 3. So b power 3 will be equal to 3 power 3. So you see exponents are the same. So what you do here, you compare bases, and you're going to conclude that b will be equal to 3. And what about b part? Jumping to b part, you have b plus 1 power 3, b plus 1 power 3, so you have b plus 1 power 3. This is going to be equal to 64. Once again, you have to express 64 in such a way that actually we have a number of power 3. And we know that 64, this is equal to 4 power 3. So taking the expression, now we'll be having b plus 1 power 3 equals to 4 power 3. You see that bases are actually exponents are the same. You have 3 here and we have 3 there. So you just compare bases, that b plus 1 equals to 4, and eventually b will be 4 minus 1, which is equal to 3. Yes, students. And we are going to jump to exercise. Actually, this is actually a chapter from your textbook, Form 2 Mathematics. So I'll pick randomly here some few questions so that you get more ideas on how we are solving these questions. And I will continue with question number 5. So with question number 5, just want to create more space here. And you go to question number 5. Forget about 6. So here you have actually 2 power x plus 1 equals to 2 power 5. You are going to compare exponents. His bases are the same. So x plus 1 will be 5. and x actually be 5 minus 1, which is equal to 4. So that is solution for question number 5. Another question, let us jump to this question here. Let us jump to this question, question number 8. And with question number 8, so this question number 8, you have 1 over 3 power xc. This is actually 81 power negative 1. So 1 over 3 is going to be 3 power negative 1. Again, power xc. This will be actually 3 power 4 power negative 1. By using power rule, this expression can be written, this equation can be written 3 power negative xc equals to 3 power negative 4. Again, bases are the same. You just compare exponents. So when you compare exponents, we see that negative xc, this is equal to negative 4. So xc will be equal to positive 4. The last two questions, and we're going to do question number 15 and the question number 16. So with question number 15, you have this is actually plus y here, and you have to find the value of y. Even though I changed the question, but I think still it makes sense. So you have 1 minus xc power 2 plus y equals to 1 minus xc power 1 over 7. So still we see that bases are the same. So I'll be comparing exponent. I'll be taking 2 plus y equals to 1 over 7. So y will be 1 over 7 minus 2. Eventually you get actually 7 here. 1 minus 14. And we are getting negative 13 over 7. So the value of y will be negative 13 over 7, dear students. And you're going to jump to the last question. The last question for today's discussion, dear students. We have another exponential equation here. So this is 2x squared equals to 288. So divided by 2, both sides, you'll be having x squared equals to 288 divided by 2. And from here, you'll be getting x squared equals to 144. But we know that 144 is 12 square. So you have x squared equals to 12 square. And eventually, you see that exponents are the same. You compare bases and we'll be getting actually xc equals to 12. So that is actually all details on exponential equation. The coming session, we're going to see fractional exponents. I hope you have understood this part very well. So you can do different questions related to this topic. If you go to chapter number 1, exercise 1.5 in your textbook, Form 2 Thai mathematics book, you can see there as many questions as possible. And so take time to go there and do all the questions. And I hope by doing that, you're going to master this topic of exponents. So we'll continue coverage, and the other session we are going to continue with fractional exponents. So that is all for today's session. If it is your first time to be here, consider subscribing to the channel so that you're going to be updated on other coming content. I wish you all the best in your mathematics learning journey. All the best in your school or students. Kwaherini.